Today, let's learn another program. Write an assembly language program to find how many bytes are zeros out of 30 bytes stored in memory locations starting at 45H. This was asked for the university exam. Now let's start the program. First, let's make some initializations. Let's choose R7 to store the number of zeros. So initially the content of R7 should be 0 and we will increment R7 each time we encounter a 0. So move R7 comma hash 00H will clear R7 so that we can store the number of zeros into it. Then let's store the count 30 into a register. Let's choose R6. Move R6 comma hash 30. We have not used H because the count is given in decimal and we are storing the decimal value into the R6 register. We are not bothering to convert it into hexadecimal. Now we have to store the starting address 45H into a register so that it can be used in indirect addressing. So the register should be either R0 or R1. Only they can be used for indirect addressing. So let's choose R0. Move R0 comma hash 45H. This will copy the value 45H into R0. Now we have finished initialization steps. Now we need to find whether a particular byte is 0 or not. We have to get each byte from the array and check whether it is equal to 0. Which is the instruction that can be used? It is the CJNE instruction. And from among the different forms of CJNE, which one should we choose? We have to make a comparison with an immediate data. So one of those forms should be chosen. And also we can use indirect addressing. So the instruction that we need to use is CJNE at RI, comma, hash immediate data, comma, relative address. So in this program, it will be CJNE at R0, comma, hash 00H, comma, L1. R0 is the indirect register to which we have copied our starting address. 00H is the value with which we have to perform the comparison. And L1 is the relative address. So if these are not equal, if the first operand and the second operand are not equal, then we will jump to L1. Let's give the label L1 somewhere here so that we have reserved some space to write the instructions where the contents are equal. So if the contents are unequal, that is R0 contains an address and the content of that address will be compared with 00H. If they are unequal, we will come to L1. And if they are equal, what should be done? That is, if our element is equal to 0, what should be done? We should increment R7. So if they are equal, program execution will come to the next instruction after CJNE, and that instruction should be increment R7. INC R7. So if they are equal, if the element we are considering is equal to 00H, we will increment R7 and come to L1. If they are unequal, we will directly come to L1. Once we reach L1, what should we do? We should increment R0 so that we can perform the next comparison. Increment R0 so that it will point to the next element. Then we should check whether the count register has reached the 0 value. How will we keep track of the number of comparisons? We have already stored the required number of comparisons in R sets. In this program, the number of comparisons to be performed is equal to the number of bytes in the array. So that has been stored in R6. So after incrementing R0, we should check whether the content of R6 is 0. We should decrement R6 and check whether its contents has become 0. If it is non-zero, we should perform the next comparison. If it is 0, R7 contains the count of the number of zeros. All 30 bytes has been checked and R7 contains the number of zeros. So which instruction can be used to decrement the count register and check whether its contents is equal to 0? The DJNZ instruction along with the count register. DJNZ R6, L2. If the count is not 0, we will go to L2 where we will perform the next comparison. So L2 should be given as the label of the CJNE instruction. So we will see if the content of R6 is 0. If it is non-zero, we will come to L2. R0 has been incremented, so it is pointing to the next element. That element will be compared with 00H. If they are equal, we will increment R7 and continue. If they are unequal, we will come to L1, increment R0 and continue. And when the content of R6 becomes 0, it means all 30 comparisons has been performed and the number of zeros is now available in R7. Let's store the count in R7 into an internal RAM location 40H. And let's end the program in a never-ending loop. Here, sjump here. Please learn this program for tomorrow. And if you have any doubts, please ask in the next class. Thank you.